Welcome to our online class. Today we are going to be discussing the coil span factor, Kc. You know, when we derived our EMF equation for the synchronous machine, we said we consider the Kc and the Kd. So we want to derive a formula, or want to find actually how to derive the coil span factor. What we are going to do is we are going to draw the phasor diagram for the full pitch winding and a short pitch winding. Now, let's get started. If I have a voltage of this nature from here, this point is point O, and this is E, this is the voltage. It gets to here, I have point A. Now, the other side, the other side also has the same voltage. So, which is going to be in phase with this, right? Now, let me extend this to this point. Let me call it B, the same voltage. This is for the full pitch winding. Now, but for the short pitch winding, this is going to deviate at an angle beta from here. This is beta. So I'm going to have a point here. Let me call this C. Now, from here to here will now be the short pitch winding, OC. If you look critically, this angle is 180 minus beta. So, and what I'm going to have here, if I do 180 minus beta, it means I can have beta here over 2. This will form what? An isosceles triangle. This is a base. So what I'm going to be having here is what? Beta over 2. Likewise, here I'm going to be having what? Beta over 2. Now, to commence now, we find the total EMF for full pitch winding. Now, for a full pitch winding, total EMF is OA plus AB. And what's our OA is E. The voltage here also is what? Plus E. And total EMF equals to what? 2E. Very good. Now, for the short pitch winding, we are going to consider this because the voltage we are looking for, or the total EMF, is actually OC. But we are not going to leave this like this. Let's bring a chord line here, like this. Yeah, very good. Now, for us to be able to calculate here, let us bring a perpendicular line from here towards this. Very good. So that I have 90 degree and 90 degree here. So I'll be able to work, and let me call this D. I'll be able to work with these two triangles. Now, this is my hypotenuse side. This is OD, and this is DC. So I'm going to consider triangle OAD. So let me consider triangle. Let me draw it out here. So I have this. I have this. This is my beta over 2. This is O. This is D. This is A. And what I have here is what? The voltage. If I consider this, because beta over 2 cosine is adjacent of hypotenuse. That is OD over OA. And our OA is what? E, which equals to OD over E. So if I equate this to this, it means that my OD is equal to what? E cos beta over 2. Very good. Now if I consider this side, let me draw it out. That is ADC. So I have something of this nature. This is my beta over 2. and I said I have ADC. ADC. Now, I'm also going to have similar voltage here. It's only short pitch winding. The voltage here is similar as voltage here. So, if I consider this again from here, cos beta over 2 equals what? The adjacent over hypotenuse. And that is going to be CD over what? Over AC. That is CD over AC. And again, our AC from here we said is E. So we have E here, which equals to what? CD over E. From here it means our CD is also equal to what? E cos beta over 2. And we told you that the total short pitch winding is what? OC. OC. So from here now, OC, total short pitch winding, total short pitch winding, OC is equal to OD plus DC. OD plus DC. What's our OD? Our OD is what? E cos beta over 2 plus, what's our CD or DC? Same, E cos beta over 2. Now, the addition of the 2 will give me what? 2E cos beta over 2. Now, what is the coil span factor? Our KC is always your short pitch winding. Don't forget, your short pitch winding over what? The full pitch winding. And that is what? Our short pitch winding here, total short pitch winding is 2E cos beta over 2 over, what is the full pitch winding? We said the total EMF for full pitch winding is 2E divided by 2E. Very good. So from here, 2E cancel, 2E we cancel. Now you can discover that our coil span factor Kc is cosine of beta over 2. That is how we arrived at that. So remember, the deal is that you must be happy, I must be happy, we must be happy. So do so well to like, comment, subscribe, and share. Thank you very much.